Okay, so today we're going to discover formulas for the derivatives of trig functions. And we're going to use them with other derivative rules that we already know, like the chain rule and the product rule and the quotient rule, to solve optimization problems. All right, so here we've got the graph of y equals sine x. We don't yet have a way to differentiate this function. We don't have a rule for how to come up with its derivative. But let's try to sketch the graph of its derivative. This is the kind of thing that I asked you to do like on the first test. Sketch the graph of a derivative. So where on this, I just have a single period of the sine function graphed here. Where are the tangent lines horizontal? Pi over 2 and 3 pi over 2 at the max and at the min. So places where the tangent line is horizontal, that means that the derivative is 0. So I'm going to try to sketch the derivative on the same axes here. So I'm going to put zeros at pi over 2 and 3 pi over 2. Okay, so now move a little bit to the left of pi over 2. Is my derivative positive or negative? Positive. My tangent line has positive slope. Positive slope. What does it look like the slope is right at 0? 1. Slope of that tangent line looks like it's a... You guys are too quick. Okay, right after pi over 2, my tangent lines are now negative, right? And what does it look like the slope is right here at pi? Negative 1. Plot negative 1 right there. And then over here at 2 pi, slope looks like it's 1 again. If I connect these with a nice smooth curve, that function that I just drew should look awfully familiar. It looks like what other trig function? Cosine x. So the derivative of the sine looks like it's cosine x, and in fact it is, and you're going to rigorously prove it in the activities. But the derivative of sine is cosine, which means that the derivative of the sine of some stuff equals what? Cosine of some stuff. Almost done. No, times the derivative of the stuff. Chain rule, yeah. The chain rule works the same with the trig functions as it does with exponential, as it does with any function. Yeah. So here we have the outside function is sine. So the derivative of the outside of function is cosine. Yep. And so we do the cosine of some stuff times the derivative of the inside, which is the stuff. All right, let's do a similar investigation to see if we can figure out what the derivative of cosine x is. Okay, so here's the graph of cosine. Where is the derivative 0 for the cosine graph? Pi and 1 and 0. Pi, 2 pi, and 0. Horizontal tangent lines at those 3 places. And then at pi over 2, the slope of that tangent line would be what? Negative 1. It's definitely negative. It's hard to see that it's negative 1 when you're using pi as your tick marks, but it is negative 1. And then at 3 pi over 2, what does the slope of that tangent line look like? Positive 1. So 3 pi over 2, comma 1. Connect these with a nice smooth curve. And that should look very familiar. What trig function is that? It is the negative sine function, right? Because it is, the sine function looks like this, right? So this is the sine function reflected over the x-axis. So it's the negative sine of x. d dx of cosine x is negative sine x. Which means that if I want to take d dx of the cosine of some stuff, how do I do that? negative sign of the stuff times the derivative of the stuff. So I'm only going to do these two for you. In your activities, you're going to derive the formula for the derivative of the tangent function. So you're going to do that yourself. And then all of them can be derived similarly to the way you'll do tangent. You should memorize these. You should know the derivatives of the 6 trig functions. The similarity between the two columns might help you with the memorization. Or put them on a note card, put them on the sheet of paper you're going to bring to the test. Have them with you all the time. At some point, you will eventually memorize them. All right, so that's it for what I'm going to do with you. And then you're going to do some practice.